So welcome to this chapter of current and electricity. Now, if we want to go to the basics of how we can understand current, current is nothing but your charge. And we have already discussed the fundamental unit of charge is the charge of electrons. We know that the charge is quantized. In our previous chapters, we have studied that the charges are quantized. That is, they appear in the integral multiples of the charge of the electrons. So if you want to study what is current, then in a way you have to study the basic movement of electrons. Now, in my previous videos, we had discussed an important concept regarding, say suppose this is a body, and if we put excess electrons, this becomes negatively charged. Negatively charged. I'm just doing a quick recap. Now, say in the same body, if you if say suppose this was neutral, this body was neutral. Now if you put excess charge, it becomes negatively charged. Now if you remove electrons from here, if you remove electrons, say suppose you have removed electrons, minus electrons you have removed. So if you remove electrons, what happens is this body becomes positively charged. This is positively charged. Now, what we can understand is all the charge that is present in the universe is basically dependent upon the presence of electrons or the absence of electron. For the objects which we call as positively charged, we merely mean that they have a deficiency of electrons. And for those objects which has a negative charge, we know that there is an excess of electrons. So this is how we can understand the basic concepts of current. Now, as I mentioned earlier, if this is your current I, say suppose this is your current I, then I is actually equal to the total charge Q. That is the total charge Q, which will be in some integral multiple of Ne, that is number of electrons, divided by the time t. Now, we know that this is a charge, total charge is Q. Now, if it's flowing at a unit time interval, that is in a unit time interval, if we look how much charge is flowing, then we can say that this is the definition of current. This is a definition of current. So this is how we can understand current. Now, say suppose you have taken for a very small interval, say suppose this is a wire. Now in this wire, electrons are flowing. Electrons are flowing. So what we need is for a very small time interval, say suppose a small time interval, say del t. Let's say time interval is del t. The difference in time interval and the difference in charge. So from time t equals to 0, or say time equals to t till del t, how much amount of charge has flown, that we can say as the is actually equal to your current with respect to time. When you write I, that is current, bracket t, that it's given function of t. Function of t. Now I often see students getting confused with this. This is actually function of t, that is the current is dependent on the time, how much time it has passed. So this is given by q upon, that is del q upon del t. Now if you take the limit, that is for a very small interval, we will get instantaneous current. Therefore I by t is actually equal to limit del t tends to 0 del q upon del t. So this is your proper notation for current, that is the current that is passing for a very small interval of time. Now another thing that we have to mention is the SI unit. Now let's discuss about the SI unit, that is the International System of Measuring Current, is The unit that is given is ampere. As we have already discussed in our chapter of units and measurements, so the SI unit of current is ampere, or it is sometimes denoted by A. So in this slide, you have to understand first what is charge, then how the flow of charge with respect to time gives you the concept of current. So this is what you can take away from this particular slide. So let's have a look now and concentrate on the flow of electricity or the flow of current in conductors. Now in this particular slide, we will be discussing about the flow of current in conductors. So why does current flow in conductors? What are conductors made up of? Now if you notice, if you look at conductors, basically all the conductors are metals. Now a bit of chemistry will be required to understand this. Now we know in metals, say this is your nucleus and this is your shell. Now we see that the chemical composition of metals is that they have in the outer shell they have electrons. And these electrons are a bit free to move. They are free to move. That is, they are not closely packed with the nucleus. This is nucleus. So you can say that, say suppose you have a numerous number of such molecules. So what we can see is that in the outermost shell, sometimes because of the combinations of millions and millions, because in one mole you will have around 10 to the power 23 molecules. So if you look at the sheer number of molecules or atoms, metal atoms that are present, you will see that there are numerous numbers, that is 10 to the power 23. So in a way you can see that there are a lot of free electrons that can move about because the ionic or the attraction between the nucleus and the outermost electron of the shell is quite less, so they're free to move. Now that is why in conductors they have this property, and for conductors you will see that wires we use only metals because of this particular property. Now moving on, what we will say is under a constant electric field, say suppose if we have put this metals into a constant electric field, we will see that the electrons orient themselves in one direction. That is, they start moving in the direction of electric field. And because they start moving in the direction of electric field. So because they start moving in the direction of electric field, we will see that there is a flow of charge. Because electrons move, we see there is a flow of charge. Now, what did we discuss in our previous slide was that the flow of charge, that is the flow of charge in unit time delta is nothing but your current. So this is how current flows in a conductor. Under a given electric field or under a given potential, you will see that there is a flow of charge, and because of the flow of charge we can see that there is a flow of current. There is a flow of current, or you can say a flow of electricity. So this is how we can understand the flow of current or electricity. Now since we are now aware of this, so let us now try to attempt to understand what is Ohm's law and what does he tells us. So here we are with Ohm's law. Now what does Ohm's law tells us is that potential, that is the amount of electric field. Say suppose this is your electric field. Now how does electric field flow? If this is E and this is negative, so the electric field will flow over here, something like this direction. the more positive negative, the more difference between the positive negative, the more strongly the electric field will be. So there is a difference between the positive negative is nothing but your potential, as we have discussed earlier. Potential. What is the potential, or what is the capability of doing work? How much capability or how much potential does a particular object have is known as your doing work or potential. So if you look over here, this is positive, this is negative. So if the difference between these two is very great, so it will be, that is, the electric will be very strong, and because of the strong electric field or the strong electric force, what we can see is it can move objects to a greater distance or move heavy objects, that is, it is doing a greater amount of work. So because of the strong electric field, it is capable of doing strong or more work, and that is because it is, therefore it has high potential. It has high potential. So this is what we can understand as potential, the capability of doing work. So when there is a huge potential difference, that is, say suppose these are 2 points. These are 2 points. This is A and this is B. The difference in between their positive and negative is great. So that is its potential. It's potential that we are talking about. Now say suppose the difference in between A and B is not that much. So we'll say that it is low in potential. This is low. Now if we say that plus and minus, or the point A and B are equal, say suppose A equals to B, we will see that there is no difference. So there won't be any flow. So I hope now we are clear with the concept of potential. Now if we are clear with the concept of potential, what it is given is the potential difference between any 2 points is directly proportional to the flow of current. The more potential it has, the more amount of current will flow. That is, the more amount of charge will flow in unit time del t. So if we increase the electric field, say suppose we have been increasing the electric field, so what we will see is, because of strong electric field, the charge Q will flow in a faster rate. That is, in a particular del t, a huge number of Q will flow. So because of that, we can see that the current increases. So if the current increases, and it is directly proportional to potential. So when we increase the potential, the current also increases, and this is what is Ohm's law. That is the potential difference. If you write this in a statement, potential difference is directly proportional. Now please keep in mind, this is directly proportional sign. Directly proportional to the flow of current. To the flow of current. So this is what we know so far. Now V is directly proportional to I, so what we can assume is V equals to a constant R into I, and that constant is your resistance. That constant is your resistance. Now what is actually resistance? Resistance is the resisting point, or the resisting force, or what we can say is a obstructing material that obstructs the flow of electrons, or you can say the obstruct the flow of charges. So this is what resistance is all about. That is, it obstructs the flow of current in a particular conductor. Conductor. Now say suppose you have a resistance. So even though you increase the potential, you will see that there is a small amount of current that is flowing. Why? Because the resistance is huge. And this is what we can understand by Ohm's law.